Hello friends, myself R.D. Mahajan presenting my video on Newton-Raphson method. A real root of the equation log of x to the base e minus x plus 3 equal to 0 using Newton-Raphson method correct to 3 decimal places. And therefore, here the given equation is log of x to the base e minus x plus 3 equals to 0. And as we require answer correct to 3 decimal places, fix your calculator for 3 digits only, and then we get answer correct up to 3 decimal places. From this equation we get therefore f of x as log of x to the base e minus x plus 3. Differentiating it with respect to x, we get f dash of x is equal to derivative of log x is 1 by x and derivative of x is 1. Therefore, we have these two equations, f of x and f dash of x. We require to find the root by Newton-Raphson method, for which we require two initial guess values. Therefore, by trial and error, if we substitute x is equals to 1, we are not considering the value of x as 0, as we know that log of 0 as minus infinity, and as that value is minus infinity, we are not considering the value of x as 0. Therefore, for x is equal to 1, we get f of 1 is equal to log of 1 minus 1 plus 3, and that is equals to log 1 is 0, therefore 0 minus 1 plus 3 we get 2, and therefore value is 2, which is greater than 0, a positive one. Therefore, for next x is equals to 2, we get f of 2 as log 2 minus 2 plus 3, and by 1.693, once again positive, means both the signs are positive, root does not lie between 1 and 2. Next, for x is equals to 3, we get f of 3 as log 3 minus 3 plus 3, minus 3 plus 3 get cancelled, and the value of log 3. And here, when we are using the calci for calculation, there are two keys for log. One is ln, that is for natural log, and log with base 10. Therefore, we are using this key log n, ln key. And for the value of log 3 as again positive. Therefore, we have to go for one more value. For x is equal to 4, we get f of 4 as log 4 minus 4 plus 3, 0.386. Once again positive. Therefore, one more value we require to find. Therefore, for x is equal to 5, we get f of 5 as log 5 minus 5 plus 3, and 0.391, which is negative. Means root lies between 1 to 5, root lies between 2 to 5, root lies between 3 to 5, and root lies between 4 to 5. Therefore, we consider the smallest interval, and that smallest interval here, therefore root lies between x is equal to 4 to x is equals to 5, as function is with opposite sign. For 4 we have positive value, and for 5 we have a negative value, and therefore out of these two values we have to consider one of them as x0, and therefore let x0 as already I have mentioned the technique. For that, observe the function value. Here it is 0.386 and for another it is minus 0.391. Which is nearest to 0? This value is nearest to 0, and therefore the corresponding value we consider as x0. Therefore let x0 is equals to 4, for which we have f of x0 as 0.386, and then we find f dash of x0. With the help of this, it is 1 by 4 and minus 1, and by first iteration we get x1 is equals to x0 minus f of x0 by f dash of x0. This is the Newton-Raphson formula, and then substituting all the values here, we get the value of x0 is here 4. F of x0 corresponding value of function is 0.386, 0.386, and divided by f dash minus 0.750, 4.515. This is the value of root, first approximation value for, and therefore we check whether this one is a root or not by finding corresponding value of function. Therefore f of x1, it is log of 4.515, log of 4.515 minus 4.515 and plus 3 minus 0.008, which is not equals to 0 when we are performing correct to 3 decimal places. And as it is not equals to 0, we have to go to the step number 2 or iteration number 2. Step number 2, iteration number 2, where x2 is equal to x1 minus f of x1 by f dash of x1, where that value of x1 is 4.515, corresponding f of x1 is minus 0.008, and f dash of x1, substituting that value of x as 4.515 here, we get 1 by 4.515 minus 1, and by calci, if we simplify it, we get minus 0.779, and then substituting all these values here in the formula, we get x2 is equal to x1 4.515 minus f of x1 minus 0.008 and divided by minus 0.779, and therefore it is 4.515 and by calci we get that value as 4.505 as the new approximation for the root. And then to check it whether it is a root or not, once again we find f of x2 by substituting this value here in this, we get log of 4.505 minus 4.505 and plus 3, and therefore it is 0.000, and as value exactly equals to 0, we stop the iterative procedure, and therefore this 4.505, and the steps required only 2. In 2 iterations only, we are getting the required real root of that equation, log x minus x plus 3 equals to 0. One more I will discuss in my next video. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel to get notification for the latest videos. Thank you.